So hi guys, so today we are going to talk about why electric current is not a vector quantity even though it possesses both magnitude and directions. Okay, so let us see what we know about vector and scalar. So we know that vector is those physical quantities, vectors is those physical quantities which possess both magnitude and direction. For example, force and velocity. So direction makes sense here. In scalar, so what we know that scalar quantities are those physical quantities which has only magnitude, for example mass and speed. So as per this definition, let us go and calculate the net force on a piece of block. The mass is 1 kilogram for example. So 10 Newton is acting, 30 Newton is acting. Both these constituent forces are acting in the opposite direction. See, direction makes sense here because it's a vector quantity. So it makes sense while calculating the net force on this piece of block. So net force. So I am just calling this particular sign criteria. Okay, the force which is acting rightward plus force which is acting leftward is minus. Fine. So net force is coming minus 30 Newton plus 10 Newton minus 20 Newton. So minus 20 Newton means 20 Newton of force is acting westward on this piece of block. Okay. Why it is happening? Because both these constituent forces are acting opposite to each other. So while calculating the net force, we take into account the importance of the direction of the constituent forces. Yes. So now what happens when both these constituent forces are acting in the same direction? For example, 30 Newton for 10 Newton acting eastward, right? So what is the net force? So again direction makes sense here. Both are acting in positive direction. So net force is coming 40 Newton. So net force, the value of the net force depends upon the direction of the constituent force. So direction is important here, right? So direction makes sense. So what happens in case of a scalar quantity? So let us talk about electric current. Electric current has both magnitude and direction, but still it is a scalar quantity. So why it is so? So for example, consider this diagram. At this junction A, two currents are meeting. They are flowing in the opposite direction, 10 ampere and 30 ampere. So what is the net current which is passing through this wire? It is 10 ampere plus 30 ampere, 40 ampere. Though the current which are meeting at junction A, they are coming in opposite direction, right? But we are not considering plus and minus. We are doing simply algebraic sum. It's a kind of algebraic sum, you can say. Right? So here, direction of the constituent current for the calculation of the net or the resultant scalar quantity doesn't make sense. So similarly, what happens when the same two current flows in the same direction, right? 10 ampere, 30 ampere. So what is the net current which flows through this? So still it is coming 40 ampere. So what we are saying in both the cases, current is coming in the same direction or opposite direction, it does not make sense, right? Because they are scalar quantity. Okay. So that is the reason actually. So why this question becomes so important for us because our definition for scalar and vector quantity is not full. Actually, it is not complete. So if we go and add one more criterion, right? Include one more criterion. So vector quantities are those physical quantities which has this, no doubt. Apart from that, the resultant vector should follow the vector rule of addition. Vector rule of addition, right? Resultant vector is required to follow vector rule of addition. Vector rule of addition means here direction of the constituent currents is meaningful. That makes sense for the calculation of the resultant vector. And here the resultant scalar quantity, right, is simply the algebraic sum of the constituent scalar quantities. Algebraic sum. So here direction of the constituent scalar quantities does not make sense. So that is the reason electric current is known as a scalar quantity. So that's all.